right, hey Josie, this is what are we on? R4. There you go. We're on example 5 and we are subtracting. Here's what I want you to do. Do this for me when you are subtracting. You ready? When you're subtracting, the subtraction sign goes for this piece and this piece, yeah? But a lot of people forget to distribute the negative. So I'm going to do that first so I don't forget. And here's what I do. I think I did this for you guys in Algebra 2 last year. I change him to a plus sign, and then I switch the symbols here. Okay, now I don't have to forget to do the negative to the very end. I just do it first and foremost, and now it's addition. Okay, we are still needing a common denominator. Okay, but I have two denominators that are kind of ugly looking.
Teachers, please dismiss the cross-country team at
Goodbye,
this time.
cross-country team. Okay, two denominators that are really ugly looking. Let's break them down. So this is a simple trinomial. What can you multiply to get 3, but when you add them, give you 4?
3 and 1.
Plus 3 plus 1. Okay, this guy is also a simple trinomial. Multiply to get negative 3, add to get 2. Plus 3 minus 1. Is that right? Okay. All right, so I'm going to do plus, because now we're doing addition instead of subtraction. And now I need to find my least common multiple, or my common denominator.
X plus 3, X
Okay,
plus
I go through the list, right, like Ellie's doing. I go through the list and I say, I need an X plus 3. Oh, what did you just do?
I just turned in 1, 2.
They all go in that that teal tray.
Okay.
Yep, otherwise I don't find them. Thanks, sir. All right, I go through and I know I need an X plus 3. I know I need an X plus 1, and I know I need an X plus 3, but do I need 2 of them?
No.
No, and I know I need an X minus 1. Oh, Daniel, sorry, I forgot to include you. I will send this to you as well, right? Here I am, like, Josie has to leave. Well, Daniel does too. Okay, here we go. So that's my common denominator, yeah? We only need 3 pieces instead of 4. Here we go, X plus 3, X plus 1, X minus 1. There we go. All right, now I'm going to write what I have, 3x plus 5 and negative x plus 5. And I'm going to write what he needs. I should do that in a different color. Write what he needs. Okay? Now, I am also going to put this front piece in parentheses as well, because if I don't, look at what happens if I don't. Here, if I don't put that front piece in parentheses, it looks like I only have to take 5 times that thing, right? So I'm going to put him in parentheses as well, so that I know I have to FOIL at the end. Okay. All right. So are we good so far? Am I going too fast? Okay. So looking at this chunk, what is he missing that he will need to have?
X minus 1.
An X minus 1. Okay. What about this right chunk? What is he missing? He will need an X plus 1. Okay. Now we're going to FOIL. Oh boy. All right. Here we go. If I FOIL this stuff, I have 3x squared minus 3x plus 5x minus 5. Did I do that right?
So,
Okay, I'm not gonna combine the middle pieces yet, because I'm gonna have more to combine with over here. So I'm just gonna combine them all at once at the end.
okay.
That make sense? Okay, I've got negative x squared minus x plus 5x plus 5. Yeah, does that work?
Sure.
Woo! Okay, down here on the bottom, I know my denominator is x plus 3, x plus 1, x minus 1. That's what my denominator is. Okay, and now I'm going to lump all of it together. I've got a mess. 3x squared can combine with negative x squared to make 2x squared. He is gone. I have negative 3x plus 5x minus x plus 5. That's 10 minus 4. Is that how you do it? Do you do the positives and then negatives and then subtract? Yeah, maybe? No? Okay. Gone, 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 gone. And then we have minus 5 plus 5. Hey!
But we can still take it X out. And a 2X. Yeah, and then we can cancel out the X
Boo.
plus 3. Right?
Boo. All right, 2x out of the top. X plus 3 left over. X plus 3. X plus 1. X minus 1. Holy crap.
So it's 2X over
2x over that junk. X plus 1, x minus 1. Holy crap. That's a lot. Man, oh man.
Wow.
That problem took a long time.
Actually,
Did we follow it? Was it good? Like you didn't like it, but you could do it, probably, maybe? If you give yourself enough patience?
if you give us the time and space.
Time and space. All right. Next.
Ew.
Complex fractions. Ugh.
What the heck
All right.
is this?
What the heck is this? All right. This guy is a big old fat division symbol. Yeah? We're going to work with the top. We're going to work with the bottom. And then we're going to slam them together.
Keep flip, flip.
We will eventually. Not yet. Okay? So this top guy, let's deal with that top guy. X over 4 minus 4 over x. Now, can we just cancel these and cancel these?
No, but they would
If
cancel
this
out.
was multiplication, we could, but right here we are subtracting, right? So here we have to find a common denominator.
4x.
4x. So 4x is going to be my bottom, 4x is going to be my bottom. I'm going to do plus and minus 4. X and 4. You see what I did?
Isn't it negative 4?
Negative 4, yes, you're right, because I slammed the negative up there. Okay, what does the x need to be multiplied by? What's he missing? He needs an x. What does he need? A 4. So this top guy is x squared minus.
16.
Oh, boo. That's a difference of squares. I bet you we're going to have to do something with that. Nah, that's the top part. All right.
Hold on, time out.
Okay. What? All right, this guy. This is my bottom guy. What's his denominator going to be? 4x and 4x. And his top is 1 and 1. And now we have to multiply by what he needs. Okay? So this first one needs an x. This second one needs a 4. Okay. So he total is x plus 4 over 4x. Okay. Now, this guy is over top of this guy, which means this guy divided by that one, right?
Or just flip them over.
So we're going to flip him. Okay. This guy is my keep part. This is my k. But when I keep him, I'm going to break the top down because I know he's going to cancel. Can I do that? I keep him. He is x plus 4, x minus 4. Can you do that? Times, because I'm flipping. This is my flip part, and I'm going to flip this. And this is 4x over x plus 4. Some of you guys have the answer already. That's awesome. 4x cancels. X plus 4 cancels. And final answer is x minus 4. Look how beautiful that is in comparison to what it was originally. Man, oh man. It's really just testing your knowledge of how you do that. You could have just guessed that, you think?
Because if you just, you know, the very top part of the fraction is x minus 4.
Right. Okay, good? Happy with that? All right, let's do another.
2.
Here we go.
Why did they throw that stuff on there?
What? I don't know. Like the negatives, you mean?
Yeah, well,
Okay,
but the,
we're dealing with the top. What does it mean when it says d to the negative 2 power? You have to flip it over. So I'm going to make it 1 over d squared. I'm not going to flip him to the bottom here because he's attached to the c. So I'm just going to make him look like that. 1 over d squared minus 1 over c squared. Yeah? That's what his top is. Okay? The bottom, this bottom guy right here is 1 over d minus 1 over c. Got it? Because it's c to the first power, d to the first power. So it's like this guy divided by this guy. Buh. Right? That's the top guy, that's the bottom guy. If we correct the negative exponents. So now what do we do?
How do you flip the whole thing? Do you put a 1? I don't
We
know.
can't flip the whole thing unless it's one piece. So we gotta make it one piece. How can I make this all one piece? What?
Just put the, I don't know. Don't ask me.
How do I make him one piece?
Oh my
No.
gosh, do the,
Find a common denominator, right? What's my common denominator gonna be? I'm gonna make that plus negative 1. D squared, c squared, d squared, c squared, or however you wanna write it. 1 and negative 1. We're gonna make him one piece here. All right, what does the d squared need? A c squared. What's a c squared need? A d squared. So this top is c squared minus d squared over d squared c squared. What a dang mess.
Do we need to do that to the other one too?
Yeah. Yeah. Okay, are we good with that? What's your common denominator? I'm going to do plus minus. What's your common denominator going to be for that one?
DC.
DC and DC. And I have 1 and negative 1. And the D needs a C and the C needs a D.
So it's just DC.
So it's just, what?
D negative.
The bottom is DC. DC. The bottom is DC and the top is C minus D. Okay. Got it?
Now we're gonna flip it.
Kinda. Yeah, sure. So it's this guy divided by that guy. Yeah? This guy right here. Before I rewrite him, the top is a difference of squares. The top is a difference of squares, right? Okay? If you can't see that, what's the square root of c squared?
C.
C goes here and here. What's the square root of d squared? D. He goes here and here. One's plus, one's minus.
Yeah.
Yeah. Then we've got d squared c squared on the bottom of that. That's my keep part. We split them apart, but that's the keep part. Times, this is the flip,
DC.
and we're going to flip dc over c minus d. Oh man, look
We'll
at that.
cancel that out.
Cancel the D and C's.
And
C
cancel
minus
that
d,
one.
c minus d is gone. Okay?
Can you cancel
C
like
plus D
divide by
over
2?
DC.
Can we cancel this dc with one of these and one of these?
Sure.
Right, sure. Okay? This, if you're confused, d squared means dd, c squared means cc. So this d is canceled with one of those, this c is canceling with one of those. So I have dc on the bottom there. You see that?
So C.
So what's left? C plus d over
CD.
cd or dc? I don't care. Which one? What a dang mess. Can this c cancel with this c and this d cancel with this d?
No.
No, the
They're
bottom's not
trapped.
trapped,
Top is.
but the top is. Yeah? What a dang mess.
That was nasty.
That was nasty. That was so nasty. That would make a good, like, bonus question on a test. Can you handle that for a bonus question? Yeah. What?
What's the point?
What's the
This.
point? You're never probably going to have a problem like that, but the point is to, like, test your knowledge of exponents and how they work, and to test your knowledge of when you have to do a common denominator like versus when you don't. Yeah.
So not necessary.
Kind of, maybe, sure. Yeah. Okay? All right, last thing. We want to rationalize on this. Have you heard the word rationalize before? Things that we want to rationalize, we want to make sure we never have a square root in the bottom.
A negative one.
We never want a square root in the bottom of our fraction, okay? So it says simplify, assume that x is a positive real number, whatever. We want to get the x, the square root of the x out of the bottom, okay? And you can do this with any square root, like square root of 3 in the bottom, square root of 7 in the bottom. This one's square root of x, so what we want to do, we can't just square it because that'll change its value. Right, if I square the top and the bottom, that'll change the value of it because now it'll be more valuable than it was before because I'm squaring the whole thing. I can't do that. I could do that if I have an equal sign and I square both sides, right? But I can't just square him to make him go away. What I can do is I can multiply by the square root of x over the square root of x. Now, why can I get away with doing that?
Because it equals 1.
The square root of x over the square root of x reduces to 1. So I am taking that thing and I am multiplying him by 1. And when you multiply something by 1, it doesn't change its value, right? It just changes what he looks like. Does that make sense? We're not changing his value, we're just changing what he looks like, okay? So on the top, what is 5 times the square root of x?
5 square root of x.
5 square roots of x. The 5 is on the outside, so he stays on the outside. Okay, what is the square root of x times the square root of x?
X.
Just x. Another way of thinking of this is the square root of x squared, right? There's 2 of them. Well, square and a square root cancel out. Okay? So there is that. What else?
Nothing.
Have we successfully gotten rid of the square root on the bottom?
I
say so.
We're done.
Dull.
That's it.
Basically, can you literally?
It's
just
kind
move
of
it
so
up?
the way one way you can think of this, Carter, like yeah, it seems kind of dumb, but this is like the equivalent of like changing 3 over to 2 to 1 1/2. It's like an improper fraction versus a mixed number. This is improper, this is a mixed number, kind of, okay? So even though 1 1/2 I think looks uglier than 3 over 2, it's like proper and not proper. Whatever. Okay, so there's that. B, I don't like square roots,
We gotta take it back.
but I have 2 square roots and there's a minus between them.
7 minus 5. 2 on the bottom.
So the problem is, I can multiply by like the square root of 7 minus the square root of 5, but that's not going to make any square roots go away. I have to multiply by the conjugate. What's the conjugate of the square root of 7 minus the square root of 5? Square root of 7 plus the square root of 5. And what I do to the bottom, I have to also do to the top. Okay? If I multiply him through, I have to like, and I can get away with doing this because this whole chunk reduces to become 1. So I'm taking this thing times 1, which means I'm not changing its value. I'm just changing what it looks like, right? Okay? All right, so on the top, I have 4 times this and 4 times that. What's 4 times the square root of 7?
Just 4 times the square root.
Just 4 square roots of 7. Whoop. 4 square roots of 7. What about the other one? Plus
4 square root of 5.
4 square roots of 5. Beautiful. Okay, on the bottom, when you multiply by conjugates, the middle 2 pieces go away, right? Yes? We've done that before, right? You don't believe me? Nod your head and say yes. Okay. All right, I can write them out if you want to. What's the square root of 7 times the square root of 5? Or excuse me, square root of 7 times the square root of 7 is just 7. Okay, what's the square root of 7 times 5? The square root of 5? The square root of 35. Okay, what's negative square root of 5 times the square root of 7? Minus the square root of 35. Okay, those are going to cancel. What's negative square root of 5 times positive square root of 5? Negative 5. Okay, so again, those middle 2 pieces cancel. If you want to just skip over them entirely, anytime you multiply conjugates together, the middle 2 pieces go away. So on the top, we have 4 square roots of 7. Actually, I'm going to write this down over here. What's 7 minus 5? 2. Is he done?
Yeah.
No.
What?
What?
You just have to cancel it out, right?
What? On the top. Can something come out of the top?
Oh,
Boo. I can pull a 2 out, or I can just reduce everything by 2. So this guy can reduce by 2, this guy can reduce by 2, and this guy can reduce by 2. He becomes a 1. Boo.
Oh, so it's nothing.
So what's he look like on the top? Plus 2 square roots of 5 all over
That's it.
1, or just that, right? You don't have to put them all over 1.
Nasty.
Yuck. Okay, that is rationalizing. So rationalizing with a monomial on the bottom versus rationalizing with a binomial on the bottom.
We don't like
Multiply by
binomials.
the conjugate. Okay? Good? You got it?
Did you send me this video?
Beautiful. Yes, I did just now. Like in the end of calc I did. Okay? Good? Happy with that? All right, so if you got through 44 yesterday, we did these 2. You have 5 problems left. For homework.
Stop your recording.
Okay? I will stop the recording and then I will